This is the lesson video for Chapter 3, Part 1. Welcome to Database Management. My name is Jose Gomez, and today we're going to cover Chapter 3, Restricting and Sorting Data. In this chapter, we're going to cover limit the rows retrieved by a query, sort the rows retrieved by a query, and ampersand substitution. In the first section, we're going to cover limit the rows retrieved by a query, the where clause, comparison operators, using the like operator, Boolean operators, and precedence rules. In limiting the rows retrieved by a query, one of the cornerstone principles in relational theory is selection. Selection is actualized using the where clause of the select statement. Conditions that restrict the dataset return take many forms and operate on columns as well as expressions. Conditions restrict rows using comparison operators in conjunction with columns and literal values. This is the syntax for the where clause. We have the select statement in the first row, and then we have the keyword distinct that's in brackets, so it's optional, and then we have the columns or expressions, aliases, and then we have the from table section, and then we have the where conditions. The where conditions are optional. Here we have two examples, so let's go to SQL Developer. Try these in your SQL HR schema. Okay, the first example, we select one column name from countries, and we specify that we want the records where region ID equals 3. So if we look at the HR table countries, go to Data tab, and we have several countries with a region ID of 3. So we only want these records. So we run the query, and these are the countries that have a region ID of 3. Okay. In our next example, we go to the employees table. We want the last name and first name, and we want those where job ID equals SA_rep. Okay. When it's a text value, we always encapsulate it in single quotes. Alright, so don't forget text is always single quotes. Alright. So if we go to the employees table, we go to the data, and we have job ID that's supposed to be SA_rep. So we go, there should be some here. So we want these records. So we run it. Okay, so these are the last names and first names of the records that have job ID SA_rep. If you notice, the value, the actual value is in all caps. Alright, so this is important because if we do anything else at caps, it will not give us any, it won't retrieve any records. Alright, so let's go to the next slide. Here we look into numeric values in the where clause, so let's go look at those. Here we get the last name and salary from employees, where salary is 10,000. So we run that, and these are the last names of the employees that have salary of 10,000. Right. For numeric values, you do not need single quotes. Alright, only non-numeric values. Alright, this is an example that Gbook has with single quotes. It'll still return values of employees that have salaries of 10,000, but do not do this, do not make it into a habit to put single quotes in numeric values. So if I ask you for, in your homework assignment, if I ask you for numeric values, queries with numeric values, and you put single quotes, it'll be marked as wrong. Now we go to character-based conditions. We have two examples, and these are looking for the last name in employees similar to the previous example, and we're looking for SA_rep. Alright, so we go as SQL developer, and these are the last names with job ID of SA_rep. And again, if you notice in employees, the values in job ID are all caps. Alright, that's important. Let me show you why. Alright, here we have the next example. It's a job ID, it's a character-based data type, and it doesn't have quotes. That's why it's giving us an error. If you had single quotes, it wouldn't give us an error. It would be just like the one above, but since we don't have any quotes, it's going to give us an error. So that's important. Any character-based data type needs to have single quotes, not numeric database type. Alright, let's go to the next two examples. This one, remember when I said that it's all caps? Job ID is all caps. So if we use mixed case, guess what? It's not going to give us anything. It'll work, but it won't list anything because we need to put cap values here. Right. Again, this next example also uses all lowercase, and again, it's going to work, but it's not going to give us anything. Remember, all the job ID values are all caps. So it's very important that you specify the exact case that the record is stored. If it was if the job ID was all lowercase, then we would get records here. Okay, now we go to date-based conditions. Okay, so we go to the job history table. We go to data, and here we want the employee ID from the job history table where start date equals end date. So if you notice, start date and equal date is not usually the same because you don't have an employee that was hired and fired in the same date, or hired and left the same day. So we're not going to get any hits because none of these are equal. It'll work, again, it'll work, but it won't give us any records. Alright, see, no employees. The next example is going to give us the job ID column from the jobs history table where start date equals July 1st, 2002. And we run this query and we get 2000. So we're looking for July 1st, I'm sorry, 200, and he was hired on, let's see, it's 200. Okay, he was hired and left, and then he was rehired again in July 1st, 2002. Now we'll continue with date-based conditions, and we have two examples. Let's look at those in SQL Developer. Again, we're getting employee ID from job history, just like the one above, and the start date is July 1st, 2002. The difference from the one above is that in the one above we spell out 2002. We spell out 2002, and here we just do 02 for 2002. Alright, it should still work, and it's the same thing as above. And it's going to give us the same employee, because this employee was hired and left, but then he was hired again in July 1st, 2002. Right. So now we go to the next date example, and we have September. It's pulling the same information, but it's for an employee that started on September 21st, 97. So how does SQL Developer know it's 1997 and not 2097? Because anything higher than any number here, higher than 50, when you only specify 2 digits for the year, anything higher than 50, it's gonna consider it from the 1900s. If anything lower than 50, it's gonna be considered from the 2000s. So we run this query, and we get employee 101, and employee 101 was hired in September 21st, 1997. Again, if you only specify 2 digits, anything above 50, it's going to consider it as the 1900s. Anything below 50, it's going to consider it in the 2000s. Okay, now we come to equality and inequality. And if you study computer science for a while, you should know all these by memory. We have the basic operators, less than, greater than, so on and so on. I'm not going to go into detail, because if you study computer science up to this point, you should be familiar with all of these. Now we have some examples of equality and inequality operators. So here we get the last name, salary, from employees, from salary greater than 5,000. We run our query, and all these employees are going to have salaries that are greater than 5,000. Okay, now we go to the next example. This is last name of employees, salary from employees where salary less than 3,000. So we run that, and these are the salaries less than 3,000. Now we continue with some examples of inequality and equality. We're getting last name, salary from employees where salary less than or equals to 3,000. We run that, and we get salaries that are less than or equals to 3,000. Let me see if we get anybody from 3,000. Yeah, here. We didn't get that one before, where it was less than 3,000. Now we want the same thing, but for salary greater or equals to 5,000. Okay, so all of these are greater or equals to 5,000. We continue with equality and inequality operators, and let's look at those next two examples. We pull the same thing, and now we want salary not equals to department ID. This is a little illogical, but why would you want salary not equals to department ID? But that's an example they gave us here in the book. So let's see if there's anything salary not equals to department ID. Well, let me run it first, and there is. So we looked at employee, where this and these are not equal, so it's probably going to give us everybody. Alright, so and now we go to another example for not equals, and in this case it's the exclamation mark and the equal signs to symbolize not equals. So we pull the same thing now with 4,000 plus department ID, and I guess in this case we're also going to put we're going to pull everybody. There might be some case where salary equals 4,000 plus department ID, but here we're looking at not equals. Now we look at two more examples, and here we're using strings to get last name less than king. So we should have anything that starts with less than the letter K. So it'll be A, B, C, D, E, F, G, H, I. So we have all those here. So any string value that is less than king, we're going to get it. Okay, let's look at another example. Here we have this is date. We're going to get less date, higher date from employees where higher date less than January 1st, 2003. And those are the people that have higher dates less than January 1st, 2003. Now let's look at these two examples. Here we're using the between operator. We run these and we get any salary that's between 3,400 and 4,000. So all these numbers are going to be between 3,400 and 4,000. So let's look at this, and this is the exact same thing as above. Notice that we have salary of 4,000, so it does include 4,000s. I'm sorry. It does include 4,000s, so it's equals to less than or equals to 4,000. So if we run this query, it'll be the same thing, right? Same as between, but this is a lot easier, to read, a lot easier to write, and you don't have to write all of this. Just write between and the two values. Okay, we have two more examples of between. We run this query and we get hire date that's between July 7, 2002 and September 21st, 2005. So we run this query and we get those records where hire date was less than, between June 7, 2002 and September 21st, 2005. Now we come to the in operator. Here we have we pick last name and salary from employees where salary in 3,000, 4,000, and 6,000. So any employees that have 3,000 in salary or 4,000 in salary or 6,000 are going to be retrieved. So let's go ahead and do that. So we get all the employees that have either 6,000, 4,000, or 3,000. Okay, so we have the equivalent if we wrote it in the long version without using in. So we would have to write salary equals 3,000 or salary equals 4,000 or salary equals 6,000. So what would you rather write, this here or this short version here? Okay, so in is very powerful and it's efficient, easier to read, easier to write. So these two are exactly the same, but this is using the in operator. Now we continue with in with string values and date. So over here we're looking for n last name that's either King, Garby, Haran, and Ramclas. We run those and we only found 2 employees with the last name of King. And now we run another SQL statement, and here we're looking for employees that will have a hire date in June 7, 2002 and September 21st, 2005. And these are the employees that have that. Okay, these are the employees that have a hire date of June 7, 2002 or September 21st, 2005. Now we come to the like operator. And here we get the first name of employees and where first name like A and wildcard. The A, that means that the first name should start with the letter A, and anything after that could be anything, and it's a capital A. So if we run this statement, you'll see that all the first names have a capital A at the beginning, and it can be any length as long as the first letter is a capital A. So this is using like with a combination of the ampersand of the wildcard, which is the percentage symbol. Here we get the first name from employees where first name is like and it's a wildcard. So it could be anything as long as it's not null, right? So to get all the first name values that are not null. Okay, so it gets everything because we didn't specify what to begin with or what to end with. We just wanted all the values that have a non null value. Now we look at more like examples. So here we run this SQL statement and we get the first names of employees where last name is King. Right. So we don't use any wildcards, so this is just like doing an equal sign. So we get the same thing as using an equal sign, just because we don't have any wildcards or the percentage symbol. Here we have well, just the previous, it's just this and these are the same, again just because we don't have a percentage sign or a wildcard. We have another example with a like operator, and here we can get first name from employees where last name, like K, starts with a K, the second letter can be anything, and the last two letters are NG, and between K and N it has to be one character because that's only one underscore. So of course we're going to get everybody that's last name is King, and we only get the first name. So again, it's anything that starts with a K, anything can be on the second letter, but the last two letters need to be NG. Now we go to the null operator. I'm sorry, S null. So we have last name, commission percent, employees, from employees where commission percent is null. Alright, so that means let's go to employees and we go to commission percent, and all these employees do not have commission. So that means they don't have anything. It's not a zero, it's an empty value. So that's why it's called null. So if we go ahead and run it, run our SQL statement, it's gonna get us all employees that don't have any commissions. Okay. Now we come to the AND operator, and here we're getting last name, commission percent from employees where commission percent, I'm sorry, the wrong one. Here we get first name, last name, commission percent, hire date from employees where first name, like J, so it needs to start with a capital J, and commission percent is greater than 0.10 or 10%. So we run the statement, and the first name starts with a J, and so all these, when we have an AND, that means that both conditions need to be true. So here we have people that first name starts with a J and their commission is greater than 10%. Again, if you study computing up to this point, you should be able to tell AND or, so all the Boolean operators or basic Boolean operators. Now we go to OR, and we pull employees with the first name and B that start with a capital B, and commission percent is greater than, or commission percent is greater than 35%. So we run this, and we have So not both conditions have to be true, but either one of them has to be true. So here we have first name of B, starts with a B, and has commission percent of null. So that means one condition was met. On the second row, the first condition of first name was not met, but has a commission percent of greater than 35%. So the second condition was met. Here, the first condition of first name like B was met, but not the commission percent of greater than 35% was met. So with OR, both conditions do not need to be true, but at least one condition needs to be true. Now we go to the NOT operator. Here we get records from employees where first name not like B. So it's going to get all the first names that do not start with a capital B. Alright, so all these first names are not going to be with a capital B. If we remove the not, it would just get the ones that start with a B. But since we put in not, it's doing the opposite. Right, so it's getting the opposite of names that start with a B. Now we continue with the NOT operator, and here we have a combination with OR. So we have the first name not like B, capital B, or not commission percent greater than 35. Since we have OR, any of these two can be true, but at least one needs to be true. Alright, so these are the records we got. Does not start with a B. Okay. Now we come to precedence rules. Again, if you've studied computer science up to this point, you should know these by heart. They're the same throughout programming languages, and I think they also in regular algebra and calculus. This is the end of lesson video for chapter 3, part 1.